Alright, so day 3 of notes. We're going to look now at the integration of natural logs. Okay? The integration of natural logs basically revolve around what we previously saw as the derivative of natural log is 1 over the stuff times the derivative of the stuff. So the integration has to be in this form. Now, another way that you can see this written on your paper is u to the negative 1 du would be the integral as far as that is concerned. When you see u to the negative 1 power, and I'm going to basically try to apply a reverse power rule method, I'm going to get some kind of error. So if I try reverse power rule, I get this u to the 0 over 0, and that's why we do not do the reverse power rule when we see this form of 1 over u or u to the negative 1. Okay? It's equal to the natural log of the absolute value of u plus c. Now, why the absolute value? Can't take the natural log of a negative. How about 0? 0 is positive or negative or neither. Can you take the natural log of a 0? No, because the domain of a natural log parent function is 0 to infinity, non-inclusive. Okay? With that being said, yes, the VA, like you saw in the other notes, or sorry, the VA, the vertical asymptote, is x is equal to 0. Perfect. All right, so now let's go ahead and do the first problem. The first problem is constant multiple rule out this 2, so that I have an equivalent of 1 over x dx. And this part right here, just by looking at our notes right now, is the natural log of the absolute value of x plus c. Right? Okay. So my answer, now some people are asking this, the natural log of the absolute value of x plus c, and all of it is multiplied by 2. They are technically correct. But we're not worried about 2c right now. We'll worry about that when we do differential equations, our last unit of the year. For now, you can still treat 2c as just c. Because the fact is, it's just a constant. Okay? Alright, so this next part. I'm going to constant multiple rule out again, and I have 1 over x dx. I have 1 to e. And the difference here is I have the natural log of the absolute value of x that is evaluated, definite integral-wise, from 1 to e. Then we will multiply by 2 thereafter. Okay? Fundamental theorem of calculus says this is equal to the natural log of e minus the natural log of 1. And the whole thing, therefore, afterwards is multiplied by 2. Why do I have written here absolute values, but here I have parentheses? Because I plugged in, and they're numeric values now. They're not variegated, just variable form answers. They're not waiting for an input. I know what they are. Okay? That's when we use parentheses. I want you just being that particular as far as free response parts. Alright, so natural log of e. What's the natural log of e? 1. What's the natural log of 1? 0. So my answer is 2 units squared. Okay, we are still looking for an area of some kind, so we'll put that unit squared because it's a definite interval. Okay? So now we'll keep going. And first intuition on this, because of what we're doing right now, might say, well, it's the natural log of the absolute value of 2x minus 1. But that's not the case because it's only when the denominator is one letter. This is a composition, if you will, so it's going to be some u-form substitution. And I have this. du is equal to 2 dx. So Travis, what's my new equation going to be? My new integral?
1/2.
Yep, 1/2.
1 over u.
1 over u.
du.
Du. Don't forget the du, please. Yep. So let's go with Bradley. What's the integral answer going to be? Final answer.
1/2 ln times u.
Not times. There's no times going on. Natural log. So natural log of the absolute value, right, of u plus c. Now that's not my final answer. 2x minus 1. 1/2 natural log of 2x minus 1. Some people missed that with bonus points today. Because it was asked in terms of x, also in respect to, we need to give an answer like this. Do I need in my answer, Peyton, do I need these absolute value signs?
Yes.
Yes, why?
Because the answer could be negative.
could be negative, it's in variable form. If there's a variable shown there, we're going to leave it as far as that absolute value piece. Okay? No units squared because of the fact that it's not a definite interval. Yes, but
That 1/2, can you move that and make it the square root?
perfect. Natural log of 2x minus 1, like the square root, if you will, like 1/2 written there, or the square root written like this, if you solve plus c.
Are any of them correct?
Say again?
Are all of them correct?
Are all of what correct?
Do you
Yes,
have
all of
to-
those.
do you
All of
have-
those.
Okay.
If you do it a certain way, if anything, I would say know them all, because whenever you're in college, you're going to be expected to know them all. But the most commonly used, in my opinion, is this one right here. You know what I mean? Just that coefficient constant at the very, very front. Okay? That's kosher, if you will.
Well, why would the absolute value be on the outside of the square root? Because if you take the square root of something, it can't be a negative number anyway.
Wouldn't it be on the inside?
Yeah.
No, I put it on the inside.
Oh, that doesn't look like the inside.
Wait, what? No?
The absolute value looks like it's on the outside.
Oh, okay. My bad. My bad. If you put the absolute value, put this on the outside, or put this here, and then you can put that square root. Here's the thing. With that in mind, just so it doesn't get confusing, use this form.
Yeah.
Okay? Use this form, you'll be fine. Okay. Yes?
Does the square root just go to the 2x minus 1, or does it go to the natural log? 'Cause you put
That's a good question. It goes just to the square root, or the 2x minus 1. It only goes to the argument. It doesn't go to the entire natural log. No. Okay? Alright, if you did not watch that video that explained a lot of that picture I sent you, law of logs, please watch it, especially that last one. A lot of people, as far as interpreting what it should be, I don't want you missing problems because of algebra 2 skills. Alright, so here we go. Megan, what's my u?
x cubed plus x.
Yes. U is x cubed plus x. So therefore du is 3x squared plus 1 dx. If you don't see it right now, this right here, this entire piece is my numerator. So I have a du over u form, or some people suggest it to be written like this because they just, I don't know, see it a certain way.
Like what?
Like see it as 1 over u du. To me, when I first learned this, guys, I was one of those people. I prefer to look at it like that rather than this. I didn't see it so easily. So it becomes the natural log of the absolute value of u plus c. But again, you were asked in terms of x. So the natural log of the absolute value of x cubed plus x plus c. That would be your answer. Okay? Alright, so let's move on. Next one. There is a typo here. My mistake on that. This 3 needs to be 1. Okay. First intuition. What do you think you're probably going to do? Factor is what some people are saying. To me, if you see that fast, that's really good. From what we're doing, first intuition might be u is equal to x minus 1, du is equal to dx, and you saw that you picked up nothing. Then you're like, well, maybe if I put x is equal to u plus 1, I can put this everywhere where I see an x. No, thank you. That's too much, especially with that 3. So the factoring is where it's going to be at, as far as that goes. So if I looked at factoring, synthetic division, I have 1, negative 2, 0, 1. And what is it going to go in the box? It's the 0 of the denominator, which is just 1. Okay? Because if it makes it 0, it's a factor. There's no remainder. Okay? So bring this down, we have 1, multiply. Add those two, we have negative 1, multiply. Add those two, we have negative 1 again. Negative 1, ding, ding, ding. My goal was to get a 0 remainder. There's no remainder. So this is perfectly divisible without a remainder. So on the top, it's basically saying this is x minus 1. The remaining piece here that factored out becomes x squared minus x minus 1. All over x minus 1, we're taking the integral so that these cancel. So all you're really integrating is a linear or a quadratic that's not hard at all, because everything else cancels. This becomes x cubed over 3, and believe it or not, they are sticklers about that equal sign as far as when you write it in this form. Minus x squared over 2 minus x plus c. There's your answer for your indefinite. Okay, first intuition, guys, I'd say 9 out of 10, all these, well, maybe not that high. Maybe like 7 out of 10. When you're doing integrals on the AP exam, you're probably going to go straight to U sub. Okay? And if not, well then it's an easy test and you're just going to rock and roll. Alright, U on this next one is 5x minus 4. If you don't see this, rewrite it that you're constant multiple ruling out that 2, and then you have that. Okay? So U is 5x minus 4. Du is 5 dx. Thank you. 5 dx. Melanie, how am I going to write my new integral?
1/5 on the outside.
1/5 on the outside with the 2 becomes 2/5. Keep going.
And then the integral of 1 over u.
1 over u. Keep du. Almost. What else, Melanie? She's in terms and in respect to you. So you got to change your bounds. Yes. Change the bounds from 1 to 3 by putting them in here to 1 to 11. Because 3 times 5 is 15 minus 4 is 11. Okay. So the answer right now from what you see is the natural log of the absolute value of u. This is evaluated from 1 to 11. And it's multiplied with 2/5. They'd be like an equal sign. Okay? T, take us away. Finish this. Natural log of 11. Did you do those with parentheses? Yes. So with parentheses, because you're already plugging them in, and then multiply it by 2/5 at the very end. Let's go with Bryson. What's the natural log of 11? Something, right?
Yeah.
Okay, good answer. Yes, something. Bryson, what's the natural log of 1?
0.
0. So my answer, 2/5 natural log of 11 units squared.
Do you not have to plug it in to find the actual value multiplied by 2/5?
What do you mean?
Like,
Oh, if it was a calculator problem, yeah, it's just plug and chug. It's going to be way easy.
okay.
But most likely it'll be written like this. What if you don't have a multiple choice question answer, okay, that's written like this? What do you think it could be a possible
Move it to the exponent.
move it to the exponent? So if you had the natural log of 11 to the 2/5, which is in the parentheses, would that work? Yes. How about if it's on the outside of the parentheses, would that work? Yes, because PEMDAS wise, this is occurring even though those parentheses aren't written. Then the natural log is applied. If you didn't remember that or learn that from Algebra 2. Okay? Is this, obviously, by the tone of my voice, you're going to say no. Natural log of 1 to the 2/5 like this equal? No, that is something totally different. You're doing the natural log first, then you're doing the power. So PEMDAS, PEMDAS, PEMDAS. Here we go. U, let's go with Caitlin. What's U?
X.
No. Never put U for X. You're never just going to do that, just a variable for a variable, because it doesn't substitute anything. You want to substitute a little for a lot. So what's U? The top. What would I write? The entire thing cubed or what? Just 1 plus natural log of x. U is equal to 1 plus natural log of x. Du is 1 over x dx. This is an understood 1 in the numerator. It's right there. Okay? So this is like u cubed du. And of course, we're going to change the bounds of Lexus to what? From 1 to 2. Yes, because the natural log of 1 is 0, natural log of e is 1. Okay? And now we just got to finish it off. This becomes u to the 4th over 4. Again, if you find mistakes whenever I'm working, which a couple of people found today, no worries. I'll give you bonus points. U to the 4th over 4 from 1 to 2. Okay, so 2 to the 4 is 16. Divided by 4 is 4. Minus 1/4. You're going to get 15 fourths. You agree? 15 fourths unit squared? Yeah. 15 fourths unit squared is that answer. Okay. Alright, so now let's go ahead and go with the next problem. Olivia, what's u?
Natural log of x
Natural log of x. Good. Du, keep going.
is
1 over x dx. Jacob, how do I rewrite my new equation?
Well, it's going to be u to the 4th.
U to the 4th
Times du.
du.
And you have to change your bounds. So it'll be from 1 to
1 to... Okay, so natural log of e squared. You know natural log cancels out e, right? So these can cancel out, and this just comes downstairs. It's 2. If you don't see it like that, law of logs. Natural log of e squared is the same as 2 times the natural log of e. I move the power now in front as a constant coefficient. What's the natural log of e? 1. So if you don't let algebra 2 miss that thing, okay? So it's 1 to 2. Now, when he was saying the actual integral, he did say times here. Is there technically times occurring there? No. Okay, there's not. On Riemann some sense, yes. But in this integrand part, there's not. Okay? We know it's occurring, but it's not to be interpreted. Okay. My integral is u to the 5 over 5 from 1 to 2. So this is 2 to the 5th is 32 fifths minus 1 fifth.
31 fifths.
Nice. 31 fifths units squared. You guys are getting this. Not too bad, right? Okay. They get a little bit involved. If anything, these are not the hard ones. The hard ones are inverse trigonometric functions like the arc tangents, the arc cosines, and we'll get to that soon. Let's go to this one. First intuition. Depending on who you are, what would you do? Okay, so u is equal to x plus 2. Some people might try to factor. But you see that top, there's no perfect square for 5. So you're not going to see a factor of some kind. So a lot of you might go straight to this. So du is dx. Did that do anything for us? No. Because if it did, this is what it doesn't do anything right now. We can't factor, so there's got to be some other way that we can rewrite a new integral. What's the new way? What do I do from here? No, not syntactic substitution. No.
You have to
Almost.
x is equal to
You solve for x.
so x
in terms of u.
minus
So there you go. This, remember, this is the sometimes. This is as difficult or involved, if you will, not difficult, involved as they get, in my opinion. X is u minus 1. 2. So if it's u minus 2, and this is where x is at, well, I'm going to put that wherever I see x in the numerator. Not the denominator, because that's u. So it becomes u in the denominator, du. The 0 is going to change to 2. The 3 is going to change to 5. And this top part is going to become this squared minus 5. So u minus 2 quantity squared minus 5. If you don't understand, please ask the question. What just happened? Okay. Now, can I integrate?
Yep. You should
Not
have
yet. I need to simplify. Just like in derivatives, we always simplified before deriving, make it easier on ourselves. We're going to do the same thing. We get u squared minus 4u plus 4 minus 5. You see that? Folding and then doing that minus 5. I'm going to go ahead and change this to minus 1 right now, just to save room and time. So minus 1 all over u du, still from 2 to 5.
Couldn't we, like, do
Yes. This right now will be u squared over 2u minus, that's a minus, 4u over u minus 1 over u. Simplify still before integrating. So I technically have the integral from 2 to 5 of u minus 4 minus 1 over u. Mike, take us home.
U to the third over
U to the what?
to the third.
Oh, no, but we're right here.
Oh.
So we came and we simplified up there.
Okay, u to the second over 2.
Yep.
Minus 4u. Minus u to the 0.
Not u to the 0. Remember, we can't do that reverse parallel because we can't divide by 0.
I can't compute.
The natural log of the absolute value of u. So minus the natural log of the absolute value of u, all evaluated from 2 to 5. Okay? Okay, so Mike, keep going.
So then you plug in 2, so you would get 4 over 2.
Not plug in 2, plug in 5 first. Remember,
Oh,
it's the
5
top.
So 25 over 2
25 over 2
minus 20
minus 20.
minus natural log of 5.
Yep, and notice how I put parentheses. Because I just plugged it in, it's a numeric piece now. And I'm going to subtract all the rest. Okay, so let me do something real quick because I don't want to go off the page. Alright, so I'm going to subtract what? 2 minus 8 minus the natural log of 2. Good. Now watch how this is going to affect those three things. Okay. We know that there's many ways that you can do this. Depending on you and your algebra, whatever you want to do, there's many ways. 2 minus 8 is negative 6. So if I'm subtracting negative 6, I'm really adding 6. So I have 25 over 2 minus 20 plus 6 is minus 14. I'm going to go ahead and put minus 28 because I want a common denominator, and now I have all my constants taken care of. Okay? Again, minus 20 plus 6 is minus 14, but I want a common denominator, so I have negative 3 halves. Now let's figure out the natural logs. I have negative natural log, or minus natural log of 5. What? Plus the natural log of 2. So this would be, right here, law of logs, true or false, minus the natural log, since they're adding 10. Do you agree? And you would be wrong. Okay? This is a common mistake. I even make it. With this, it should be minus natural log of 5 minus natural log of 2 in parentheses. You with me? Look what I just did. From this piece here, I factored out a negative. Because it's subtracting, it's really 5 halves. You understand? It's really 5 halves that's going on. It's negative 3 halves minus the natural log of 5 halves. And this is, go ahead.
Well, you can make it positive and then put the negative 1 to the exponent.
You could also put a 2/5,
Right.
but it's not going to be 10. It could be plus natural log of 2/5. You're right. You're absolutely right. But my whole thing that I'm trying to make sure that you know is that the first one that you're doing, when you combine them, its power or its value has to be positive. You know what I mean? That's why we or factored out that negative, because inside parentheses we're interpreting it as a positive natural log of 5. Good. Okay? So this is my answer, and it is units squared. Just like Jake said, if you wanted to change this to a positive, you can. It'll be negative 3 halves plus that negative is basically moving over there, and it's going to be that 2/5 piece that you're interpreting. You agree? Okay, so natural log of 2/5. Either one, probably this one is what most people might do. Okay? Alright, so let's keep going. Now, what is the derivative of cosine? No, the derivative. Negative sign, yes. What is the derivative of sine? Cosine. So, remembering where we're going, what's the integral of cosine? Sine. The integral of sine is negative cosine. 2 of 6, they're easy to remember. But the other 4, they're a little bit more involved to remember. Please memorize them. 2 have 2 different ways that you can memorize them. But if you don't, you're going to have to do this work, what I'm about to do on your test. I'm telling you, you don't have time to do that. You got to memorize these. One thing that makes Calc 2 so difficult in college is that this is just 4. There's like at least 30, maybe to 40 of these things that you just have to memorize. And they're involved. Most people, and I'm not joking, 60% of people will take Calc 2 twice. At least twice, because they failed it the first time. You're not in that boat. No one in this class should be in that boat. Most people that graduate from Prosper go straight to Calc 2 and score A's easily. Okay? Because little do you know, you've learned about 65% of it already. Alright, so here we go. The integral of tangent of x. Okay, we're gonna derive, and I don't mean differentiate, but to create, we're gonna discover the formula from what we know of u substitution. Tangent is sine of x over cosine of x. So u is cosine of x. Du is negative sine of x dx. So that my new integral is negative du over u, which equals the negative natural log of the absolute value of u plus c. It was asked in terms of x. Because it was asked in terms of x, I will answer in terms of x. It'll be the negative natural log of the absolute value of cosine of x plus c. Who sees an alternative form to answer this? You could move that negative to like a negative 1 power, law of logs. So this negative 1 could go up, and it could be like this. Do not think this as arc cosine. This is not the same as the arc cosine, because this aims at finding an angle. This right here is synonymous with secant, which is 1 over cosine. So this is inverse of, this is inverse. You remember when we talked about that long ago? Inverse cosine, inverse of, so inverse cosine, which is synonymous with arc cosine. Inverse of cosine, which is the same as that. So the other form, the other way that you could write this is the positive natural log of the secant of x plus c. In my experience, not only in college but with also the AP exam, I'd say most often than not, textbooks or answers are looking for that one. Because they don't like negatives the way I don't like negatives, and the way most people don't like negatives. Alright, next one is the cotangent. The cotangent is cosine over sine. U is sine of x, du is cosine of x dx. So that I have a du over u, no negative is interpreted. And then it's just going to be the natural log of the absolute value of u. The absolute value of u is sine. It was asked in terms of x, so I'm going to go straight to the answer. Is there an alternative form that you can see? Like, remember, these two are equivalent. They're both are acceptable. If you do one or the other on the test, I will accept it. Just don't put a negative down here where you're not supposed to, or leave this positive, vice versa. Is there another one that you can think of for this? It would be a double negative. You really don't want to do that. Because it's like the negative natural log of cosecant. You know what I mean? And it's like, you don't want to do that. Okay? Double negatives, I just got what you said. Anyway, let's go to secant. Secant's different, and so is cosecant. the question that you're going to ask probably whenever you see the proof of it is why? Why that? You know? And I'm just going to say, why not? You know, there's so many different things that you can do to get an answer. This is just one suggestive way to find it. So, how to remember this for you guys. This is my best offer to you to quickly memorize these two. Think. Of course, think. What is the derivative of that normally? Secant tangent. All positive, right? Okay. So I want you to think about it like secant tangent. We know that this is secant tangent. And because everything's positive, I want you to go ahead and realize this is the form of 1 that you're going to multiply by. Why? Why not? So here, this was positive, positive, so you're going to think of that. This is your form of 1 that you're going to multiply with that. So think of this like a fraction. Distribute the two numerators together, and you now have written secant squared x plus secant tangent, secant x tangent x. And on the bottom, it's going to be just what you have, secant x plus tangent x. What would you suggest as u now? The denominator. So all this now is my u substitution. And I'll say u is equal to secant x plus tangent x. And look how nice it just worked out for us. The derivative is, what's the derivative of secant? Secant tangent. So we got to go back and memorize those 6, magnificent 6 that we called them way long ago, the 6 trigonometric functions. Secant is secant tangent. Secant x, tangent x. What's the derivative of tangent? Secant squared x. How convenient for us, this right here, oh, I forgot a dx, is right here. So this is a du over u form. So all this simplified to du over u, which we already know by now, is the natural log of the absolute value of u plus c. All we need to do is plug back in our u value right here. So it becomes the natural log of secant x plus tangent x, absolute value, plus c. There's my answer. And I'm going to say don't try to come up with a different form on this. This is probably the more preferred one because everything's positive and blah, blah, blah. Yeah.
Where did the plus come from?
The plus, I'm just telling you to think of it. This is just a memorization tool. It just came from the fact that I needed to multiply by a form of 1, and there's my form of 1. It almost feels, if you're with me, nod your head or whatever, it almost feels like conjugate. You know when you're multiplying by forms of conjugate, forms of 1, trying to get the conjugate out of the denominator, it almost feels like that. When you're doing it, your goal is to get the derivative of the denominator on top of the denominator. Okay? Okay. Alright, cosecant. Of course, what do you think I want you to, not actually write, but think about, what's the derivative? Negative cosecant cotangent. He's like, thank you, save me. Alright, the derivative of cosecant of x is negative cosecant cotangent. I want you thinking about it. The reason why is because of this negative. Just like Taylor was saying, why is it plus? Well, here I'm thinking negative. I want you to write this form of 1 as cosecant x minus cotangent of x. Remember, this is just a suggestive way to prove it out. A suggestive multiple form of 1 to figure it out. It's still multiplied with cosecant of x dx. And then the top becomes, when we distribute it, cosecant squared minus cosecant cotangent all over cosecant x minus cotangent x. I'm going to erase this over here because I need room. Alright, so let me get rid of this. Let's go with Andrew. What's U?
It would be cosecant minus cotangent.
Yep, U is cosecant x minus cotangent x dx. Oh, sorry, no dx, not yet. Andrew, what is du?
It would be or negative cosecant cotangent.
Good. Negative cosecant cotangent. Keep going.
Or minus sine.
Okay, let me ask you this. What's the derivative, Andrew, of cotangent of x? What's the derivative of cotangent of x? If you can picture it, if you were visual, it's the sixth one, second column on the bottom. It's the negative cosecant squared of x. We're subtracting the negative cosecant, so it's truly adding cosecant squared of x dx. And if you notice, just like from before, this whole thing is our numerator right here. It's just in the wrong order. Or, you know what I mean? It's equivalent. You have the negative cosecant cotangent, and over here you had it subtracting. And then you have the positive cosecant squared, and over there it's there. So this is still another du over u form. So the integral is the natural log of your u term. Your u term is this guy. So it's cosecant x minus cotangent x. To me, guys, this is the best way that I can give to you to memorize it fast. Okay? Alright, so now let's go to this thing right here. To make sure that you have these memorized in the forms of that it can be, or you know how it can change as far as what you would write comparatively to what other people would write. This right here could also be written as the natural log of the absolute value of secant of u plus c. So one or the other. The one I would prefer on the test is probably that one. But again, if you do the other one and it's correct, you'll get just as much credit. Alright, this one, there's really not a form, and I wouldn't want you to do that whole cosecant. I wouldn't really want you to do that. I just say leave this as that. So the same. Okay? No difference there. Let me highlight for you for the sake of the video. Those are one or the other. The secant is another one that I would prefer you not to change it up. It's going to be that. And when you start doing problems, you'll know what I'm talking about depending on the order the pieces are given to you. And then what was the one that we figured out with this one right here?
It was positive.
It was a positive cosecant of u minus cotangent of u. This right here, it's a weird form the way this one works. There's a lot of getting common denominators. There's a lot more algebra. This is not just a simple, oh, it's just the flip, it's just the reciprocal, because it's not a monomial. It's two monomials. It's a binomial. But that subtraction sign says there's a lot more going on if you were to move that here. Okay? But it simplifies for the sake of time. I'm not going to do all that. It simplifies to what we found in the proof in the last thing. So these two are the other ones that are variants, or varying as far as how you're going to answer. Okay. I'm looking for the integral of 3x. Now, if you can see the shortcut, use it. A lot of people in this class, I think, will see the shortcut. But if you're a little bit leery about it, don't use it until you've practiced with WebAssign or a lot of problems with whoever. Looking at this, u is 3x, du is 3dx. If I rewrote it, I have 1/3 tangent of u. Again, if you catch a mistake, you let me know. The integral of tangent of u. Don't think secant squared, that's the derivative. The integral is what we just learned. Okay? What's the integral for tangent? The one that I preferred you to write. Natural log of the absolute value of secant. So it still relates with secant, but not secant squared. So the secant of u, the absolute value, it's the natural log. The 1/3 is multiplied, and it's plus c. But this is not my answer because it was asked in terms of x. So I have to put it as 1/3 natural log of secant of 3x, absolute value still because of that variable x, plus c. Or like some people did, the negative 1/3 natural log of the cosine of 3x. We good? Please do not work ahead. Everyone did get this answer, so I'm not going to work it out, but for the recording purposes, I will just establish that this was your u, and that the final answer became 1/3 the natural log of secant of x cubed plus tangent of x cubed. Absolute values because of those x's plus c. Now, looking at this, those of you who want to identify a shortcut, this is a 1/3 piece, if you will, right? There's your 1/3. Looking at this, your u is going to be here, and it's basically never mind, I don't want to show you the shortcut because it doesn't work all the time.
No, we did the shortcut.
Never mind. No.
That was pretty short.
Okay, never mind. If you see it, I'll let you use it, but it's a little bit more involved, especially when your u is more involved. I'll let you discover it if you see a shortcut, but I don't want to confuse people. That's why I'm not continuing with it. There you go. Let's do this one together. If you look at this first glance, what would you do first?
Split it up.
U is equal to a bunch of stuff. Don't do that. A lot of people, first intuition, might want to put u for a bunch of stuff, split it up. The integral of 5 in respect to x minus the integral of cotangent of x over 3 in respect to x. Now you really only have one problem. The cotangent of x over 3. Because you know this piece over here is going to become 5x minus something. So what's the something that we're looking for? We're looking for that. So don't even pay attention to that negative sign. We're just going to solve it as if it was cotangent of x over 3 all by itself. Here we go. U is x over 3. Du is 1/3 dx. Again, we're just solving this, not really looking at anything else. What's the new, anybody? What's the new integral? 3 times cotangent of u du. Okay, cotangent. Think of a cotangent. What's the answer there? The what? Natural log of the absolute value of sine. So what am I doing? I'm trying to help you memorize them as we speak. The natural log of the absolute value of sine, and it's going to be of u, which is x over 3, plus c. Now this 3, it's still out here, yes or no? Yeah. So if I'm looking at this, this is that piece. When I subtract it, I get 3 natural log of sine of x over 3. And there it is. If I looked at this, I know the cotangent is going to be a natural log of sine of something. The something is still there. All I'm doing then is taking the derivative and taking an inverse or a reciprocal of that derivative, and that's its coefficient. Subtly, there's the shortcut. If you see it, you got to do more problems to be able to see it. But you'll develop it as far as whether to use it or not. If you don't, work it out. Okay. Let's go now with the average value of f of x. So if I want to know the average value of a function, that function goes where? In the integrand. It goes inside of the integrand. That's where I'm going to put the function. So if I want to know the absolute or the average value of velocity, what goes in the integrand? The velocity, not the acceleration as some people would think. I was one of those people. I'm trying to find the average velocity. Why shouldn't I put the acceleration? It yields the velocity. No, that's not how it works. Alright, so this is going to be 1 over 2 minus 0 from 0 to 2, and it's going to be of secant pi x over 6. Okay. Let's go with Kelsey. What's u? Yep. Kelsey, what's du? Pi over 6 dx. Okay, so careful. 1 over 2 minus 0, we know. I can go ahead and just write that as 1/2. So when I write my new, Jake, when I write my new integral, what would I write?
You can pull out the pi over 6 and flip it.
So pull out the pi over 6 and flip it. So we got 6 over pi.
And
Secant of u. Keep going. So you need to remember this, right? So 1/2.
Sure.
Sure. So it's 3 over pi. We can go ahead and write that right now. 3 over pi. Secant of u is good. I gotta do my bounds. I gotta change those bounds. So this and this will change to. So plug it in there. Yep, 0 to pi over 3. Was that Allie?
Yeah.
Thank you. Secant of u du. The integral of secant. I'm wanting you to think about what? The derivative of secant. Okay, so that's secant tangent. There's a positive. So it's going to be secant plus tangent. There it is. So secant u, which is this. Oh, wait. I don't even have to put that in. What am I doing? Don't do that. You already changed it to u. Leave it in u. So secant of u plus tangent of u evaluated. This is the absolute value, the natural log, evaluated from 0 to pi over 3. And then the 3 over pi is at the outside. A lot of algebra, right? A lot of freaking algebra. No calculator. So, what? Because it's the integral. Okay, here we go. If you have forgotten, which I bet maybe 60% of us in here have, pi over 3 is here. 3, 2, 1. 3, 2, 1. What is the secant now? Because I'm going to plug this in. It is 2. So the secant of 1/2 is 2. What is the tangent of pi over 3? Root 3. So technically I have the natural log of that minus, here we go, the natural log of, let's plug in the 0 now. What's the secant of 0? 1. What's the tangent of 0? 0. What's the slope there? 0. Y over x is 0. So this is basically multiplied all with 3 over pi. Don't forget that parentheses or you'll only multiply that 3 over pi by the first piece. But it doesn't matter because the second piece is what? What's the natural log of 1? 0. So my final answer yields 3 over pi natural log of 2 plus root 3, no units squared, because this is a y value. Okay? Context of what it's asking. How was that? Not too bad? Okay. Just a lot of algebra. Parentheses, negatives. If you forgot this stuff, guys, revisit. Alright, here we go. It says a population of bacteria grow at a rate, so there's a derivative, where t is in time and days, and my initial population is 3,000. What t value would you say yields 3,000? 0. Will that be the case always? No. In these that are not mentioned, that's interpreted as the default. T is equal to 0. So t, not t. What's my position function? This is that. So my position is this, right? So P of 0 equals 3,000. That's that. And I'm trying to find the function that gives the population at any time. So we're solving for the differential equation. So let's integrate plus C, plug in, find C. Okay, here we go. P of t is equal to the integral of this right here. Here we go. 6,000 1 over 1 plus 0.5 t dt. You agree? Alright, now what is the integral of this right here. Well, I gotta make room. Let me write it up here. We have 6,000, 1 over 1 plus 0.5 t dt. U is 1 plus 0.5 t. du is 0.5 dt. Let's go with Bradley. What's my new equation going to become?
Integral
1 over u du. What's outside Bradley?
times 6,000.
Almost. 12,000. Yep. Because that dividing by 1/2 or multiplying by the reciprocal is going to yield 12 grand. Okay? So 12,000. The integral right here is the natural log of the absolute value of u. U is this, is this guy right here. So here we go. We have 12,000 times the natural log of the absolute value of u, which was 1 plus 0.5 t. Correct me if I'm wrong. Plus c is equal to p of t. But I need to find c. 3,000. Will that work all the time? Not all the time, but most often than not it will. Okay? Plugging in. If I plugged in this value of 0, which is t, my initial time, here, I end up saying the natural log of 1, which is 0. 0 times 12,000 is 0. So plus c to yield this 3,000, that's going to come over here. C is 3,000. So my answer is going to become, I'll just erase the c and put 3,000. Done. That's part A. Use your answer to find part B. You're just going to plug in 8 for t. Be done. Let's do it a different way. I don't know why I put this in notes. What's the faster way to find this if you had a calculator? Like this. Here we go. Because of the fact that this said initial, we know it's 0. I can do final minus initial is going to yield that displacement. Remember that way long ago, that integral is equal to its first fundamental theorem. Is equal to f of b minus f of a. So if I go from 0 to 8 of this guy right here, so I'm going to call it p prime of t. You see what I'm doing? This is equal to f of 8, which is what I'm looking for, minus f of 0. What's f of 0? 3,000. The way that you'd probably see this on the AP exam is f of 8 or f of x is equal to 3,000 plus 0 to 8 of the derivative function in respect to time. They'll give it to you where it's all by itself, and that f of a value that used to be here is now on the right side or the same side as the integral. So there's your initial value. This is the displacement that occurred over 8 minutes of time, which will yield your final value. If that didn't help you kind of solidify first fundamental theorem, go back and revisit first fundamental theorem because it's everywhere. All right, so what's the answer on that? If you were number crunching? P prime of t is that actual value here. It's the 6,000 over 1 plus, they gave you the derivative.
I got 22,300.
Yep, thank you. 22,313.255.
That's what I
Let me go and write that down. 22,313.255 is P of 8, the population of the bacteria at 8. I will accept this, but I mean, really you can't have 0.2355 bacteria when you're talking about population. So I would accept this, but I would prefer that you write, because you know this, of what I just explained, you can't have that percentage of a bacteria right into the whole number. Thank you. These notes are nice, man. Let's keep going. All right, so real quick, for the sake of time, I'm not going to work this all out because I want to try to work out one problem, but we'll give you the answers. This one is 1/3 natural log of the absolute value of 3x minus 4 plus c. The next one came out to 2/3 3x minus 4 1/2 plus c. Or you could put that as a square root if you wanted to. Next one came out to x squared plus 4 over 8. This is to the 4th power plus c. This one came out to 1/6 sine of 2x cubed plus c. And then the last one simplifies to root 2 over 24 minus 1 over 48, or if you want to combine it, to root 2 minus 1 over 48 units squared. And this is a lot of work. I do have a little bit of time. I'll at least set it up. U is cosine of 2x. du is negative sine of 2x, 2dx. There is a lot to keep up with. So du is negative 2 sine of 2x dx. Rewrite, and I'll let you figure it out from here. Pi over 8 to pi over 6. No, hold on. Change of bounds, my bad. I'm looking at something else. It's, say again?
So it's 1/2 square root of 2 over 2.
So root 2 over 2 to 1/2. If you keep it as this, or you can flip it and make it a positive 1/2. U squared du, and then you solve it